Well, today NVIDIA is a household name for many, but it was not always so. More than a decade ago, NVIDIA was mostly recognized for its role in rendering 3D graphics and powering gaming experiences. With its powerful GPUs, it was revolutionizing how millions of gamers enjoy their favorite titles. However, even in those days, there was a foresight of something bigger, something beyond just rendering beautiful graphics. It was a foresight that these GPUs held immense potential beyond gaming, laying the groundwork for the emergence of the artificial intelligence revolution that we see today. Who would have thought that these same GPUs that bring joy to gamers would become the unsung heroes of artificial intelligence? It's almost like learning that your favorite toy is now running world's most sophisticated algorithms. Think about leveling up from playing Donkey Kong to training neural networks. In the history of AI, the journey began long ago. The research began in 1950s and 1960s. But there was one event in 2012 that propelled modern AI into the spotlight. Two students from the University of Toronto embarked on a journey to create image recognition program. Their innovation lay in usage of a technique known as neural networks, a branch within machine learning where a computer learns a task by analyzing pre-labeled data sets. Neural networks are modeled loosely according to the intricate workings of a human brain. They have a very large number of processing nodes that are interconnected and organized into layers through which data flows. But there was a challenge. Traditional computing power couldn't cope with the scale of neural networks. So enter GPUs. With thousands of processing cores, they seemed like a perfect fit for neural networks. Leveraging this power, the students created a program that's now known as AlexNet. Upon its entry into the competition, AlexNet achieved groundbreaking results, outperforming everybody else by a wide margin. This event marked the beginning of a new era in AI, one centered around the classification or interpretive AI. In the classification AI, we are teaching the model to categorize data and interpret it. As an example, in this image, a properly trained model would recognize a picture of an adorable dog, distinguishing it from other animals like cats and rabbits. The success of AlexNet not only proved the prowess of neural networks, but it also paved the way for advancements in AI that we see even today. AlexNet proved that by using GPUs, neural networks could become a reality. In recent times, a fascinating new realm of AI has emerged, known as generative AI. In a traditional AI, we are training the model to categorize and interpret the data. Generative AI flips the script. In generative AI, we are trying to teach the model to generate the content. Consider this problem. If you're trying to generate an image, one image may have 1 million pixels. Each pixel is defined by 3 numbers representing color. So what we're asking a model to do is effectively pull 3 million pixels from a random distribution, giving us an image. But through model training, we can teach the model to recognize patterns in this seeming randomness and generate a coherent image. Remarkably, we do not know the underlying mathematical function that is governing this process. However, through model training, we can teach the model to recognize the patterns and pull the coherent image. Take a moment to appreciate this fact, this absolute miracle that we don't even know how it works, but it generates a coherent images. Today, generative AI is going even further. generative AI is now working with multiple sources of data, not just a single source, not just text and not just images. The emergence of multimodal models where they're trained on text, images, audio, and video is helping us in fields like computer vision and robotics, where visual data is combined with text and audio. The scale of today's AI models have reached unprecedented heights. Today's models are capable of absorbing billions of images and trillions of words. To achieve this feat, they require tremendous computational power. It is obvious that traditional GPUs, a single GPU, or even a single server with multiple GPUs in it, is no longer enough to provide this computational power. So we're entering an era of cloud computing specifically tailored for the purpose of artificial intelligence. AI data center, and specifically AI data center powered by GPUs, requires a paradigm shift in data center design. The power requirements are different. The network requirements are different. Even the cooling requirements and the spatial density in a data center has to be different. This prompted the reinvention of the data center for AI workloads. Moreover, today's training is so complex that we require sophisticated tools for massively distributed computing. Today's models are trained on tens of thousands of GPUs. Try to imagine these vast data sets flowing at tremendous speeds throughout the network as these GPUs are gobbling up trillions of words. And this process can last for months until the model starts to converge. The convergence in deep learning marks the point where the network has stabilized and the parameters of the network have settled on the values that are producing accurate predictions for the training data set. All this brings tremendous complexities into an already complex world of cloud computing. So to abstract some of these complexities, new serverless platforms are needed. The term serverless is somewhat a misnomer because servers are still required. However, it encapsulates the transformative paradigm shift in cloud computing. On serverless platforms, developers and researchers can focus solely on building and deploying their models. It's almost like electricity coming from the grid. You do not need to know where the electricity is generated, how it's transported, how it gets to your house, but you just plug in the appliance and it works. Similarly, with a serverless platform, the abstractions of the serverless platforms allow developers to focus only on building and deploying their models and not worrying about underlying servers and infrastructure. This flexibility is especially important in the realm of generative AI, where we require tremendous computational power. By utilizing GPUs that are in the cloud, the serverless platform can provide seamless scalability, enabling both small startups and large enterprises to use as little or as much as they need to rapidly innovate and iterate on their solutions. Serverless platforms have the capability to provide seemingly infinite scale, bridging many servers and even multiple data centers, all while providing enhanced security. Remote access to models, combined with the enhanced security, facilitates the development of user-facing applications that are powered by AI and that can enrich our everyday experiences. As we embrace the future of AI, let's also recognize the transformative impact that serverless architectures have on advancing AI and enhancing our experiences. In conclusion, it's crucial to understand that AI is not something to fear. Rather, it's a tool that holds immense potential to revolutionize every aspect of our daily lives. From healthcare to entertainment, AI will become ubiquitous, enriching our experiences and enhancing our capabilities. And just like humanity has learned to harness the power of once potentially dangerous elements like fire and electricity, I'm sure we will similarly adapt and thrive alongside AI. Let's embrace this future with optimism, recognizing AI's potential to improve our world and propel us towards a better tomorrow. Thank you.